The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, today we're going to go on to Objective 3B. So let's go ahead and get started. Suppose we had the following. 13 minus 3 equals 10. Well, 13 minus 3 does equal 10. So we get 10 equals 10. So this is a true statement. And it's also an equation because it has one side equal to another side. Okay. Suppose, however, we had the following statement. Y minus 3 equals 10. Now we have a variable, an unknown, that is y. And for some of us, perhaps it's obvious that y is 13. For others, maybe not. Maybe we're still waking up. But an easy way to make it obvious what y is would be to isolate y. That is, isolate the variable. Well, there's something called the addition property of equality that basically says this. If you have an equation, something equal to something else, you can add the same quantity to both sides of the equation, and that is perfectly legal, and the resulting equation will have the same solution as the original equation. So let's say, for instance, we take the equation y minus 3 equals 10, and we add 3 to both sides of the equation. On the left side of the equation, y minus 3 plus 3, the minus 3 and the plus 3 cancel, and we have y equals. And on the right side of the equation, 10 plus 3 is 13. So we have solved the equation by isolating the variable, y equals 13. Again, by using the addition property of equality. Any questions about this example? All right, let's take a look at some other examples. Let's say we have the following. M minus 7 equals 16. To isolate m, that is to solve the equation, we could add 7 to both sides of the equation. On the left side, we would get m. On the right side, we would get 23. Again, any questions about that example? All right, let's take a look at some more examples. 9 equals w minus 4. To isolate the variable w, we will add 4 to both sides of the equation. On the left side of the equation, 9 plus 4 is 13. On the right side of the equation, w minus 4 plus 4 is just w. So we get w equals 13. Any questions? All right, here's another example. Z minus 5 equals negative 9. To isolate z, we'll add 5 to both sides of the equation. So we get z equals negative 9 plus 5 is negative 4. So z equals negative 4. All right, suppose we have the following. X plus 5 equals 12. To isolate x, we need to get rid of the positive 5. Well, we can do this. We can still use the addition property of equality, and we can add negative 5 to each side of the equation. On the left side, the plus 5 and the plus negative 5 cancel out, and we get x equals 12 plus negative 5, which is 7. However, isn't this just the same thing as subtracting 5 from both sides of the equation? So we can still use the addition property of equality, but we can add the same quantity to both sides, or we can add a negative quantity to both sides, or we can subtract the same quantity from both sides. I've seen textbooks that actually have the subtraction property of equality, but we can put that underneath the addition property of equality. So what we get is this. If we have an equation, we can add or subtract the same quantity to both sides of the equation. All right, so let's take a look at some more examples. X plus 9 equals 14. So I'm going to subtract 9 from both sides of the equation to isolate the variable X. Any questions there? If I'm going too fast, let me know. 7 equals X plus 4.6. So I'm going to subtract 4.6 from both sides of the equation. And that's going to give me what? 2.4 to 7 minus 4.6. We borrow and carry, that's a 4, 2.4. Okay. What about this equation? 12 plus n equals 7.5. So we'll subtract 12 from both sides. On the left side, we get n. On the right side, let's see, 7.5 minus 12. Well, I can do that on my calculator. 7.5 minus 12 is negative 4.5. Again, as I've mentioned, if you have any questions concerning how to use the calculator, please ask, and I'll be happy to demonstrate things. Otherwise, I'll just continue on. All righty. Let's say we've got this problem. 5 plus y minus 9 equals 4. In this case, before we isolate the variable, we're going to simplify both sides of the equation. On the left side, I have y, and then 5 minus 9 is minus 4 equals 4. Now I'm going to go back and isolate the variable term by adding 4 to both sides of the equation. We get y equals 8. I haven't done this up until now, but let's do this. Let's check our work. How do we do that? We take the solution and put it in the place of y to see if that's true. 5 plus 8 is 13. 13 minus 9 is 4. 4 equals 4. So when y equals 8, we get a true statement. So the solution is y equals 8. All righty. Let's see here. How about this one? X minus 3/4 equals 3/4. So to isolate x, we'll add 3/4 to both sides of the equation. 3/4 plus 3/4 is 6/4, which can be reduced down to 3/2. So we get x equals 3/2. Any questions? All righty. How about this one? W plus 7/8 equals 3/8. So to solve for W, we'll subtract 7/8 from both sides of the equation. The plus 7/8 and the minus 7/8 cancel. So W is 3/8 minus 7/8, which is negative 4/8, which could be reduced down to negative 1/2. Any questions there? All right. Let's say we've got the following. 2/3 plus y equals 3/7. So to isolate y, we'll subtract 2/3 from both sides of the equation. However, we can't easily subtract 2/3 from 3/7 until we get a common denominator. The least common denominator of 7 and 3 is 21. So we get that situation. I'm going to multiply the first fraction by 3/3, which gives us 9 over 21. I'll multiply the second fraction by 7 over 7, which gives us 14 over 21. So now y equals 9 minus 14 is -5 over 21, and that doesn't reduce any further. Any questions about that? All righty, give me just a second here. Suppose we have something like this. X over 4 equals 12. Well, the variable term has been isolated, but the variable itself still has a number attached with it, okay? X over 4, that's like 1/4 X, same thing, okay? Now, not only can we add or subtract the same quantity to both sides of an equation, we can multiply or divide both sides of an equation by the same non-zero number. This is called the multiplication property of equality. So recall back when we were solving proportions and we had an equation and the coefficient of the variable was a fraction. We multiplied both sides of the equation by the reciprocal of the coefficient. The reciprocal of 1/4 is 4 over 1, or just 4. So now on the left side of the equation, the 4 is reduced down and I have 1 times x, or just x. On the right side of the equation, 12 times 4 is 48, divided by 1 is still 48. Any questions about that example? Okay. Let's say we've got the following: 9y equals -27. Well, I could multiply both sides by the reciprocal of 9 over 1, which is 1 over 9, and I get y equals -3. However, that's the same thing as just dividing by 9. So again, under the multiplication property of equality, we can multiply both sides or divide both sides of an equation by the same non-zero number. In this case, y equals -3. Any questions about that example? All right, let's say we've got the following: 3x equals 15. To isolate the x, we can divide both sides by its coefficient. On the left side, we get x. On the right side, 15 divided by 3 is 5. Again, checking our work, we would put 5 in the place of x, and we get a true statement. Any questions there?
Yeah, I had a question.
Sure.
Okay, so like with the, the insert, the symbols, like a positive or a negative. So basically it has to show the symbolism, like if we're doing like the addition property or like, how we're doing multiplication property right now.
Mm-hmm.
So like basically it would have to have like the positive or negative, right? And then you'll know like which one you're doing, like with the property.
I'm a little confused.
So like, how like you divided or you said multiplication of the reciprocal,
Uh-huh.
like how we just did addition. Like how would you know the difference? Like, is it with the symbol?
Okay, this is what I think you're asking me. Let me know if this is wrong. Let's say you've got this problem
Okay.
versus this problem.
Yeah, I get what you're
Yep.
saying.
Okay, in the first equation, the 3 is being subtracted. So I need to add 3 to both sides of the equation to isolate the x.
Okay.
In the
All right.
second equation, the 3 is being multiplied. So I need to divide both sides. Is that what you're asking about?
Yeah.
Okay, yeah. So be careful. You undo subtraction with addition. You undo multiplication with division.
Okay, I got you now.
A common mistake is people will do this. That's
Yeah.
not correct. Yeah. Okay, we
Okay.
good?
Yeah, we're good.
Yeah.
Thank
good
you.
question. You betcha. All right. What about this one? -8n equals -56. Well, the coefficient of n is -8. So I will be dividing. I'm not subtracting. I'm dividing. That fraction bar tells me I'm dividing both sides by -8. -56 divided by -8 is +7. All right. What about this one? -x equals 7. The implied coefficient of x is a -1 with just the negative sign there. So I'm going to divide both sides by -1. So x equals -7. Any questions about that one? All right, let's say I have 4a equals 0. To isolate a, I will divide both sides by 4. So I get a equals 0 divided by 4 is still 0. Okay, let's see here. -15 equals 48z. I will divide both sides by 48. On the right side, I get z. On the left side, I can reduce -15 48ths. I can divide the top by 3 and the bottom by 3, and I get -5/16. Okay. Any questions there? All right, give me just a minute here. Let's say we've got 5/9 x equals 10/3. Here, the coefficient of the variable is a fraction. So just like we did with solving proportions, we'll multiply both sides of the equation by the reciprocal of the coefficient of the variable. The variable is x. The coefficient is, well, that was weird, was 5/9. The reciprocal of 5/9 is 9/5. So on the left side of the equation, 9/5 times 5/9 reduces down to 1. 1 times x is x. On the right side of the equation, 9/3 reduces to 3/1. 10/5 reduces to 2/1. 2 times 3 is 6/1 is still 6. Any questions about that? Okay. What we're going to do now is we're going to look at some problems where we have to use both the addition property of equality and the multiplication property of equality. Suppose we have the following. 4x plus 3 equals 11. So we need to get rid of the 4 and we need to get rid of the 3. But the order in which we do this is important. And here is sort of the mantra I'm going to give you, and that is this. Isolate the variable term, then isolate the variable. Isolate the variable term, then isolate the variable. Okay, so to isolate the variable term, we got to subtract 3 from both sides. To isolate the variable, we've got to divide both sides by 4. So I'm sort of undoing order of operations. Order of operations, you multiply or divide, and then you add or subtract. Well, in solving the equation, undoing it, we go backwards. So we add or subtract and then multiply or divide. But we isolate the variable term and then isolate the variable. All right, let's do another one. 5y plus 9 equals 24. So what would we do first? Anybody?
-9.
Minus 9. So we've isolated the variable term. And then what would we do?
Divide by 5.
Right, isolate the variable. So isolate the variable term, isolate the variable. Let's check our work. So we'll put y or 3 in the place of y and see if we get a true statement. We do, so y equals 3 checks. Okay. Let's see here. How about this one? Negative 12y minus 7 equals 29. So what are we going to do first?
Add 7.
Right. Isolate the variable term. Good job. And then
Divide negative 12 on both sides.
excellent. Isolate the variable. Positive divided by negative is negative. Excellent. Good job. How are we doing? Are we okay with this new thing? We're putting 2 ideas together. Okay, just a minute here. Let's see here. Okay. How about the following? 4/5 z minus 7 equals 13. So what are we going to do first? Isolate the variable term. Go ahead, Brandon. You going to say something? Oh, okay. So we would add 7 to both sides of the equation. 4/5 z equals 20. So we've isolated the variable term. Now we're going to isolate the variable. Since the coefficient is a fraction, we'll multiply both sides by its reciprocal. And if you need to put the 20 over the 1, just to remind you what's going on, that's fine. On the left side, the 4s and the 5s are reduced down to 1s. 1 times z is just z. On the right side, 20 over 4 is 5 over 1. 5 times 5 is 25. Z equals 25. Any questions there? Okay. 8 equals 4 minus y over 7. To isolate the variable term, we'll subtract 4 from both sides of the equation. 8 minus 4 is 4. 4 minus 4 is 0, so I have negative y over 7. Well, negative y over 7 is the same thing as negative 1/7 y, isn't it? So the coefficient would be negative 1/7. We'd multiply by negative 7 over 1, or just negative 7. On the left side, -7 times +4 is -28. On the right side, negative times negative is positive. The 7's reduced down and we get y equals -28. Any questions about what I just did there? Okay, let's see here. Okay. 5/8y plus 5/6 equals 13/6. So we're going to isolate the variable term by subtracting 5/6 from both sides of the equation. I get 5/8y. The plus 5/6 and the minus 5/6 cancel out. On the right side, 13/6 minus 5/6 would be what? 8/6, which I could reduce down to 4/3. Okay. Any questions so far? Now, to isolate the variable, I'll multiply both sides by 8/5. The reciprocal of the coefficient of y, the 8's and the 5's reduce down and I just get y equals. And on the right side, I get 32/15, nothing reduced out of that. Any questions there? Okay, let's see here. How about this one? 4.8k minus 9.2 plus 6.3k equals 13. So before I do any isolating, I'm going to simplify each side of the equation. On the left side of the equation, combining like terms, 4.8, let's see, 4.8k plus 6.3k is 11.1k. So I have 11.1k minus 9.2 equals 13. Next, I'll go in and add 9.2 to both sides of the equation. So 11.1k equals 22.2, adding those up. Then I'll come back and divide both sides by 11.1. So I get k equals, let's see, 22.2 divided by 11.1. We'd move the decimal over one place and it goes in exactly 2 times. Any questions there? Okay, let's see here. How about this one? K over 2 minus 1/3 equals 1/4. So the first thing I'm going to do is add 1/3 to both sides of the equation. So k over 2 equals, well, I've got what, 1/4 plus 1/3. To add those, I need a common denominator, which is going to be 12. So I'm going to multiply 1/4 by 3/3 to get 3/12. I'll multiply 1/3 by 4/4 to get 4/12. And 3/12 plus 4/12 is 7/12. Okay. You okay with that so far? Then to isolate the variable, I'll multiply both sides by 2. The 2's reduced down and I get k. 2/12 is 1/6 and I get k equals 7/6. Okay, let's see here. Just looking at what kinds of things they throw at you here. Okay. How about this scenario? 4m plus 3 minus 5m equals 7m plus 8. I know it looks like things keep getting bigger and bigger and more complicated, and you're right, they are. So the first thing we're going to do is simplify each side of the equation as much as we can. So on the left, we'll combine like terms. 4m minus 5m is negative 1m or negative m, and then plus 3. And on the right side, there's nothing we can do. Oh, well, now we have the variable on both sides of the equation. That hasn't happened before in today's lesson. So we need to pick a side, either side of the equation. It doesn't matter. Pick a side to put all the terms with the variable on it. People tend to put them on the left. That's what I tend to do. It doesn't have to be on the left. It can be on the right, but let's go ahead and put them on the left. So to put the variable terms on the left, I have to get rid of them on the right. So I have to subtract 7m. But if I subtract it from the right, I must also subtract it from the left. Whatever I do to one side of the equation, I have to do the same thing to the other side of the equation. So now on the left side, negative m minus 7 more m is negative 8m plus 3 equals 8. So now the variable term is just on one side of the equation. Whatever side of the equation I put the variable term on, I want to put the constant term on the other side of the equation. So now I'm going to subtract 3 from both sides. I get negative 8m equals 5. Now, to isolate the variable, I'll divide both sides by negative 8. So m equals negative 5/8. Now, notice I took this and I wrote it like, whoops, that's not right. And I wrote it like this, or I could also write it like that. You don't want to leave an answer with a negative sign attached to the denominator. You want to either apply it to the numerator or out in front of the entire fraction. So a lot going on there. Did I lose anybody on that problem? Nope. Okay, excellent. We'll continue then. Let's see here. 7y plus 8 minus 2y equals 11 minus 3y plus 5. So I'm going to simplify both sides of the equation first. I'll do that by combining like terms on the left side of the equation. 7y minus 2y is 5y, and then plus 8. On the right side of the equation, negative 3y, and then 11 plus 5 is plus 16. Notice I'm doing something. I'm doing something, yeah. I'm writing the expression on each side of the equation in standard form. I'm putting the variable term and then the constant term. Okay, so now I've simplified both sides of the equation. I'm going to put the variable terms all on the left. So I need to get rid of the one on the right. I do that by adding 3y to the right side. But whatever I do to the right side, I have to do to the left side as well. So now I've got 8y plus 8 equals 16. Since I put the variable term on the left side of the equation, I want the constant term to be on the right side of the equation. So 8y equals 16 minus 8 is 8. And finally, isolating the variable, divide both sides by 8, y equals 1. Let's check our work. We're going to put 1 every place that y appears in the original equation. 7 times 1 plus 8 minus 2 times 1 equals 11 minus 3 times 1 plus 5. 7 plus 8 minus 2, 15 minus 2, 13. 11 minus 3 plus 5, 8 plus 5, 13 equals 13. It checks. You okay with that? Okay, let me take a peek here. See what else. Yes. Okay. How about this? 6 times the quantity, 7k plus 3 equals negative 12k. So again, we're going to simplify each side of the equation first. Okay. On the left side of the equation, 7k plus 3, those are not like terms. So I can't do anything to simplify inside the parentheses. I'm forced to distribute. So I'm going to take 6 times 7k, which is 42k, and then plus 6 times 3, which is plus 18, equals negative 12k. Any questions there? All right. So now I want to put all the k terms, all the variable terms on the same side of the equation. Let's see. Well, if we put them on the left, we would do this. We would add 12k to both sides. On the left side, I get 54k plus 18 equals 0. Well, since I put all the k's on the left, I need all the constants on the right. So my next move is going to be to subtract 18 from both sides of the equation. So now I've got the variable term on one side of the equation and the constant term on the other. I'm going to go in and divide both sides by the coefficient of k. K equals, I can divide the top and the bottom by 18, and I get negative 1/3. And there we have that. Any questions about that problem? Okay, let's see here. How about this one? 2k minus 3 times the quantity. Don't need to leave so much room there. Minus 3 times the quantity k minus 5 equals 6. Simplifying each side of the equation, we get 2k. And then minus 3 times k is minus 3k. And minus 3 times minus 5 is plus 15 equals 6. So we distribute. Then combining like terms, 2k minus 3k is negative 1k plus 15 equals 6. So k is only on the left. So let's get all the constant terms on the right. So we'll subtract 15 from both sides. Negative k equals 6. Take away 15 is negative 9. Then we'll divide both sides by the negative 1 coefficient. K equals negative divided by negative is positive. Let's check our work. If k is 9, 2 times 9 minus 3 times the quantity 5, 9 minus 5 equals 6. Order of operations, you do what's in the grouping symbol first. 9 minus 5 is 4. Multiplication, 18 minus 12. Subtraction, 6 equals 6. So the solution checks. Be careful. A mistake people will make sometimes is they'll check the results and then they'll say, oh, the answer is 6. No, the answer is 9. But when we get 6 equals 6, that shows that this makes this equation true. So it is a solution. Okay, let's see here. How about this one? 3 minus 2 times the quantity, 3W minus 4 equals 7 times the quantity, W minus 4. Put that a little bit closer. All right, so we need to simplify both sides of the equation. On the left side of the equation, we get 3 minus 6W plus 8. Distributing the minus 2 times 3W is minus 6W. Minus 2 times minus 4 is a plus or positive 8. On the right side of the equation, distributing the 7W minus 28. We're going to go back to the left side and combine like terms. Negative 6W plus 11 equals 7W minus 28. I'm going to go ahead and solve for W. I'll do it on the right this time. So I'm going to add 6W to both sides. 11 equals 7W plus 6W is 13W minus 28. I have all the W's on the right, so let's put all the constants on the left. We'll add 28 to both sides. 11 plus 28 is 39. 39 equals 13W. Divide both sides by 13, and we get 3 equals W, or W equals 3. Any questions there? Okay. Let's take a look at this one. The quantity 2y plus 5 plus the quantity 8y minus 3 equals the quantity 7y minus 2 minus the quantity y minus 9. Okay, so to simplify both sides of the equation, on the left side, with nothing in front of the parentheses, we just bring down the contents. With a plus sign in front, distributing that, we again just bring down the contents. On the right side, nothing in front of the parentheses, we bring down the contents. A subtraction sign, distributing that, changes the sign of each term inside the grouping symbol. So now we've gotten rid of the parentheses. Okay. On the left side of the equation, we'll combine like terms. 2y plus 8y is 10y. 5 minus 3 is plus 2. On the right side, combining like terms, 7y minus y is 6y. Minus 2 plus 9 is plus 7. So now we've simplified both sides of the equation. Okay. Let's put the variables on the left, which means we need to get rid of them on the right. But since I subtract 6y from the right, I have to subtract 6y from the left as well. 10y minus 6y is 4y. 4y plus 2 equals 7. Since we have the variable term on the left now, we want the constant term on the right. So we'll subtract 2 from both sides of the equation. 4y equals 5. And now to further isolate the variable, divide both sides by 4. Y equals 5/4. Again, be careful about the instructions. As I've been correcting your tests, a lot of people missed problems because they didn't follow the directions. Like, for instance, maybe they wrote 1 1/4 on one of their problems and it said, write it as a fraction. That's not a fraction. So again, be sure to read all the instructions on both your homework and your tests. Okay, let's see here. I think that's all I've got for you today, and I know that's a lot. I will be back at 1:15 with an office hour. Should you have any questions, I'm going to go ahead and stop the recording.